Good morning, dear students. Myself, Dr. Priya, working as Associate Professor in Chemistry Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. In today's session, we are going to learn about what are the specifications that were given by WHO or BAS for potable water or drinking water, we will call it as, and then what methods we can adopt for disinfection treatment of potable water. So, under that, chlorination is the best method. Several methods are there. In our syllabus, we have only chlorination topic. So, this breakpoint chlorination is nothing but a subtopic of chlorination. So, let us start with specifications of potable water. So, the following are the specifications that were given for potable water, or we can say drinking water. The water which is used for drinking water purpose is what we call it as potable water. So, it is having some kind of specifications. Let us see one by one. So, it should be sparkling clear. The water should be very clear. That means it doesn't have any kind of suspended solid particles. At the same time, it should be odorless. That means it shouldn't have any smell. And then most important thing is it should be very pleasant to taste. So, pleasant taste that water should possess. That is one more important specification. And then it should be perfectly cool. That means at room temperature it should be cool. And then it shouldn't exceed its turbidity value, that is 10 ppm. It should not exceed turbidity value 10 ppm. Its turbidity should not exceed 10 ppm. And then that potable water should be free from any kind of dissolved gases like hydrogen sulfide H2S, CO2, like that. It should be free from dissolved gases content. And then it should be free from some kind of minerals like lead, arsenic, chromium, and then manganese salts. So, these will come under heavy metals also. So, water should be free from these kind of metals. And then alkalinity property should not be high. That means it should be always less than 200 ppm. And its pH should be actually neutral, but some relaxation it is given. It is in a range of 6.5 to 8.5 can be acceptable. Sometimes it will be like 6.5 to 8 also. So, and coming to the next one, it is very soft. That means water should be soft water, reasonably soft. That's why it is mentioned like reasonably soft, because drinking water should have some content of minerals. If they are getting exceed, they need removal. So, that's why they should be reasonably soft in nature. And then TDS content should be less than 500 ppm. That means total dissolved salts content in the water should be less than 500 ppm. So, TDS content should be less than 500 ppm, and then it should be free from disease producing microorganisms. That means no pathogenic organisms should be present, bacteria, fungus, algae, like that, because those are able to impart or those are able to show their adverse effects on living things. Like if water is having microorganism content, if we prefer that one as drinking water, for drinking water purpose, it is able to cause waterborne diseases like diarrhea, cholera, typhoid, such kind of diseases it is able to cause for living organisms. So, it should be free from that disease causing or producing microorganisms content. Okay, and if it is for the case of chloride ion, it should be less than 250 ppm. The amount of chloride ion presence should be less than 250 ppm. Fluoride ion content, if it is present in excess amount, that means it is crossing its permissible limit value, that is 1.5. It is highly dangerous or hazardous to the human beings. So, always it should be less in content. That means less than 1.5 ppm it should be present. Like this sulfide ion should be less than 250 ppm. Okay. So, and last but not the least, water should be free from dissolved gases like CO2, H2S. So, these are the specifications that were designed by WHO, World Health Organization, regarding drinking water. So, let us go for disinfection treatment of potable water. Disinfection treatment of potable water. The process of killing or destroying the disease causing microorganisms like bacteria, algae, fungi and all, etc. from the water, and making that water as safe for drinking water usage is called disinfection. For this process to take place, some kind of chemicals we need to add, which are called disinfectants. So, the process of destroying or killing disease-causing bacteria, microorganisms, that is like algae, fungi, etc. from the water, and making that water safe for drinking water purpose is called disinfection. And the chemicals that we are going to use in this process are named to be disinfectants. The chemicals or the substances that are added to the water for killing the bacteria are called disinfectants. So, there are several methods we can adopt, but what is the best suitable method that we have to see. So, it can be done. The disinfection treatment can be done several methods, as I told you. Let us start with the first and most traditional method, that is boiling. So, generally in a domestic purpose, from in olden days, we used to boil the water for at least 10 to 15 minutes so that disease producing bacteria, that is microorganisms like bacteria, algae, fungi, they get killed and water becomes safe for its usage. So, this is a traditional or we can say oldest method, but this is used, or we can prefer this kind of boiling method for less amount of water, that means domestic kind of purposes, drinking water purpose. If it is like huge amount, we cannot adopt this kind of boiling method, but this is one of the oldest and traditional methods. So, what is the next method? Coming to this disinfection treatment of potable water, second method we can use is bleaching powder, addition of bleaching powder. What is bleaching powder? CaOCl2, calcium hypochlorite, calcium hypochlorite, CaOCl2. So, this can be added to the water by knowing the proper proportions. That means 1 kg of bleaching powder is to be added. That is calculated proportions are like this. 1 kg of bleaching powder is to be added for 1000 kiloliters of water, and it is kept undisturbed for several hours so that reactions will take place in this manner. When bleaching powder it is mixed to water and it is kept undisturbed for several hours, then what will happen? It is able to release chlorine gas. It is able to release chlorine gas along with calcium hydroxide. This chlorine gas which was produced will combine with water molecules present in the water sample. Chlorine will combine with water. So, as a result, it is able to produce HOCl, that is called hypochlorous acid. HOCl along with that HCl will also be obtained. This hypochlorous acid is a very good germicide. It is having germicidal effects. It is a very good example for germicide. So, if this HOCl it is produced in the water, it is able to kill the germs or pathogenic organisms that were present in the water sample, so that the water becomes free from the disinfection, right? So, this is second method. First method, it is oldest and traditional method, that is called boiling the water. Second one is simply by adding bleaching powder, that is calcium hypochlorite. So, most preferable and suitable best method is chlorination, that is simply by adding chlorine. Chlorine can be added to the water sample either in its gaseous form or liquid form. Gaseous chlorine, that means chlorine gas is allowed to pass into the water sample so that formation of hypochlorous acid will take place, and we know that hypochlorous acid is a very good germicide, so that it is able to kill the microorganism content that is present in the water sample. So, this is simply by adding chlorine gas. Chlorination can be done in another way also, that is by adding liquid chlorine to the water sample. By adding liquid chlorine to the water sample, by adding liquid chlorine to the water sample, in that case also hypochlorous acid will be obtained as one of the products, which is a very good example for germicide. So, let us see what is chlorination. So, chlorination is the process, or it is defined as the process of purifying the drinking water by producing a powerful germicide like hypochlorous acid in the water. By adding some kind of disinfectants, it is able to generate, those are able to generate or produce hypochlorous acid itself in the water body. So, as a result, this microorganisms will be killed. When this chlorine it is mixed with water, it is able to produce hypochlorous acid, that is HOCl. It is a very good germicide, as I told you, it is able to kill the microorganisms that were present in the water sample. Generally, if you notice the pH value of chlorine, it is basic in nature, that means greater than or equal to 7. If there is any fluctuation takes place in this pH value, that means it is more effective with this pH value 1. That means greater than or equal to 7. If it is becoming less, then it becomes ineffective. If there is any fluctuation in its pH value, it becomes ineffective. It will act like more effective or much effective over the germs if it possesses a basic pH value that is greater than or equal to 7. Hence, because of this kind of advantage, chlorine it is widely used all over the world as a powerful disinfectant. When this is added in proper proportions to the water sample, what will happen? It is able to generate a hypochlorous acid, as which is an example for very good germicide, and it is able to kill all the germs present in the water sample. For this process to carry out, we need to depend upon an apparatus that is called chlorinator. So, chlorinator is a kind of apparatus or device. This is nothing but its structure. At the top, it is like a tall tower, and it is provided with 2 inlets at the top. One is meant for allowing the passage of water, which should be disinfected, and the other one it is meant for allowing the passage of chlorine, either in gaseous form or liquid form. So, these are baffle plates. Baffle plates are meant for refraining that water sample, which is having microorganisms content. After refraining, what will happen? This chlorine, it is able to mix it with that water content vigorously. I mean to say, entire microorganisms get killed by this addition of chlorine gas to the water, and these are very much able to mix up that entire water content. These baffle plates are able to mix up the entire water content with chlorine that we have added. So, as a result, it is able to refrain the liquid, that is water fluid. So, it becomes free, or we will call that one as sterilized water, which is free from entire microorganism content. So, this is a kind of apparatus that is called chlorinator, into which we have to allow the passage of water from one inlet, which is to be disinfected, and using the other inlet, we have to pass either chlorine gas or liquid chlorine. So, with the help of this baffle plates, water becomes free from microorganisms content. So, there are some advantages and disadvantages for this chlorination, that is using chlorinator method. And coming to advantages part, it is more effective and then economical also. And then during this process, there were no salt impurities. At the end of that disinfection, it is not able to release any kind of salts. That is one more advantage. So, if there were no salt impurities, then it is good for drinking water purpose. And then we know that chlorine, it is commercially available in purest form. So, that is one more advantage. No, it doesn't need any kind of purification before its usage. And then storage, it requires very less space for storing chlorine, whether it is in gaseous form or in liquid form. It requires very less space. So, storage is not also a big problem. So, these are different kinds of advantages for chlorination, which is most preferable and suitable disinfection treatment. So, apart from all these things, it may have some kind of disadvantages. So, let us go with that one. So, first one is bad taste. If excess of chlorine content is there in the water, that means we have to add chlorine content on proper calculation we have to add, right? That means we have to check how much amount we need to add first, and then go for actual treatment method. Say for example, if residual free chlorine content is there in the water sample, then it is able to impart bad taste to the water, and it is also able to give some kind of unpleasant smell or unpleasant odor to the water sample. That means if excess amount of chlorine it is added, then these are the effects: bad taste and unpleasant odor. So, and then irritation on mucous membrane if it is used in excess. So, when human being's body it is exposed to over dosage of chlorine, then there is a chance for causing irritation on mucous membrane. So, that's why calculated proportions only we need to add. Excess amount if it is added, it is having some kind of disadvantages. And as I told you, if its pH it is greater than or equal to 7, then it behaves like an effective method. So, if any fluctuation takes place in its pH value, then it becomes ineffective. Coming to the next one, that is breakpoint chlorination. So, as I told you, if chlorination it is done by adding chlorine content to the water sample, we don't know how much amount we have to add. So, that can be done by calculating its breakpoint. So, by knowing the breakpoint, for addition of chlorine, we can reduce its disadvantages, that is causing a bad taste to the water and unpleasant odor to the water. So let us see how it is. So by chlorination, what will happen? As we know that organic matter and disease producing microorganisms were completely eliminated, which are responsible for imparting bad taste and bad odor to the water sample. So this can be done by using a method called chlorination. Chlorination is nothing but simply by adding chlorine either in gaseous form or liquid form. It is able to kill that microorganisms content due to the formation of hypochlorous acid. So calculated amount of chlorine must be added to the water, because after the reaction is completed, that means after it is able to kill the microorganisms content, then it will remain in the water as residual chlorine, which is able to impart bad taste, bad unpleasant smell, and even if it is more in amount, it is highly toxic to the human beings. So we need to add only calculated amounts of chlorine to the water. If residual chlorine will be there, that means remained in the water sample, then it is able to impart these kind of effects to the human beings. And certain amount of chlorine is added to the water, it will lead to the formation of chloramines or chloro-organic compounds. So whenever we are going to add certain amount of chlorine to the water sample, so what is the first step that is going to take place? So it is nothing but formation of chloro-organic compounds and chloramines. So this will be done due to the oxidation of reducing compounds that were present in the water sample. So and then next what will happen? If you go on adding that chlorine content to the water sample, at a certain point, that means after a certain amount of chlorine that is added, the point at which free residual chlorine begins to appear is what we call it as break point. So let us see what is that break point. The amount of chlorine required to kill bacteria or microorganisms or removing the organic matter is what we call it as break point chlorination. So this break point, after calculating this break point value, we are able to notice whether further chlorine is to be added or not. That means it's nothing but a stop or a full stop for addition of chlorine content to the water sample. So this is the graph that is, or this is the curve which is able to reveal that what is the break point and how much amount of chlorine is needed for water content, for removing the microorganism content. See this along the x-axis, this is nothing but amount of chlorine that is added, milligrams per liter, and this y-axis is able to reveal us the residual chlorine content. If you notice, up to this extent, there is no addition of chlorine, right? So let this point is represented like A, small a. I am going to represent this starting point as small a. What do you mean by small a? Amount of chlorine that is added. A grams of chlorine is added. Before that, there is no addition of chlorine. So exactly at the point A, I have added A grams of chlorine. So this is step 1, stage 1. So after adding chlorine, what is happening? Up to this extent, we can notice a change. That is, let this point be B. In this curve, let this point be B. So up to this one to A to B, it is called curve 2. That is stage 2. Stage 2 or curve 2. That is, this added chlorine is able to involve in oxidation. It is able to involve in oxidation with reducing compounds, and thereby it is able to produce chloramines. Chloramines were produced in stage 2. That means up to B, formation of chloramines will take place, right? So if you notice again, that means still you are going to add chlorine content. That means still that addition of chlorine, it is continued. That is what this curve is explaining, right? So from B to this point, one dip we have noticed here. So this is, I am going to represent this point as C. The curve from B to C, if you notice, there is a decrement in the residual chlorine content. Up to A, it is 0. After A, that means adding A amount of chlorine, it is getting increased and reaching the point B. Reaching the point B. This is the increment, right? So free residual chlorine, it is going to increase up to point B. So after reaching point B, that is from B to C curve, if you notice, again we can have a decrement in the residual chlorine. If you go on adding, what will happen? it will get reduced. It is going to reduce. That is what we call it as A. It is nothing but point A states that A grams of chlorine it is added. A to B, nothing but formation of chloramines will take place. Formation of chloramines will take place. That is from A to B curve. And B to C. Okay, we can notice destruction of this chloramines. Destruction of chloramines. These chloramines are able to act like germicide, so that they are able to kill that microorganism content that is present in the water sample. That means disinfection it is completed. This B to C point. So this is B and this is C and this is A. So from B to C, we can notice the free residual content it is getting decreased. That means the obtained chloramines in curve A to B are able to destroy the microorganism content that is present in water sample. So exactly at point C, entire microorganisms were destroyed. So there were no microorganisms to destroy in water sample. That means this point C is named to be breakpoint for chlorination. Breakpoint for chlorination. That means we have to stop the addition of chlorine exactly at C. That means if you reach the point C, then there is no question of adding further chlorine to the water sample. That means there is a breakpoint obtained for chlorination process. This curve is able to reveal us, right? So what happens if I go on adding? That will be represented in this curve also. That is from C to D. What is C to D curve represent? C to D is a curve. It is going to represent that again there is an increase in residual chlorine content. Free residual chlorine content it is going to increase. Here it reached a minimum. It's not equal to 0, but it reached the minimum. That means we got a dip, right? So minimum value for this chlorine content, free residual chlorine content. If you go on adding, what will happen? Entire microorganism content it is removed. There is no use in adding further chlorine content to the water sample, and it will be reflected back in the curve as CD curve or CD stage, that is stage 4, in which we can notice an increase in the free residual content. So CD represents free residual curve content. So hence this point C is what we call it as breakpoint for chlorination. So this is A, B, C is nothing but a dip where we notice, that is breakpoint for chlorination, and this is D. So this is about breakpoint chlorination. So far what we have discussed in today's classes, first one it is specifications of potable water, that is drinking water, that were given by WHO, World Health Organization. And second one is disinfection treatment. Disinfection treatment. Disinfection treatment method for drinking water. In that several methods we discussed. One is boiling. Second one is addition of bleaching powder, that is calcium hypochlorite. Third one is most important one, that is chlorination. Chlorination it is considered as best suitable method for disinfection treatment for water sample. And what happens if excess amount of chlorine is there, free residual chlorine is there in water sample? So this can be studied by a topic called breakpoint for chlorination. Breakpoint for chlorination. So these are the topics so far we discussed in today's session. In the next session, we are going to study about boiler troubles. What happens if hard water is used in boilers for steam generation. So that's all for today's class. Have a nice day. Thank you so much.